Lesson 10 on page 477, which is function notation and problem solving. So we're going to skip right to example 1. A candle manufacturer found that their long-last candles melted according to this formula, where H is the height of the candle after T hours. So part A says to use a graphing calculator to sketch the graph. Now, because we're doing this online, we have reduced the objectives, so I don't actually expect you to be able to use your graphing calculator to do this. So what I'm going to do instead is I'm going to give you the graph, and then you're still expected to answer all the other questions given the graph. So if you did do this in your graphing calculator, you would get a straight line, and it would have these intercepts. You would have this intercept at 12, and you would also get an intercept at 6. I would expect you, though, to be able to figure that out algebraically, what these two intercepts would be, because they actually gave you the equation. So you could simply plug in for t or h of t and figure out those intercepts. So the first question says, determine the value of h of 5, which means that we're going to plug in 5 for the time, and we're going to figure out what that ends up being. If you plug that in your calculator, you're going to get that it's equal to 2. This is the important part. Write the words in words the meaning of h of 5. So 5 represented the time, and h of 5 represents the height in centimeters. So when I am looking for a response for something like this, I'm looking for two parts. So h of 5 represents the height of the candle after 5 hours. So notice that this has two parts to it. I talked about the height of the candle, and I specified that this was 5 hours. So if you just said the height of the candle, that would not be correct. You have to incorporate that 5 hours. So you're showing the relationship between these two variables. Evaluate the following and explain their significance. So we're looking at h of 0. So we're just going to plug in 0 for t. So that ends up being 12. H of 6, we can plug in 6, which ends up being 0. At H of 8, we can plug in 8, and that ends up being -4. So in the first example, it says, what is their significance? They're asking you to interpret what this means. So h of 0 equals 12 means that at time 0, the height of the candle was 12. So you could say that the candle started at 12 centimeters high. So the candle started 12 centimeters high. So the key is understanding that t of that if t is 0, that is the very, very start of the experiment. So the key word here is started. Now this 0 means something different because the time in this case is 6. So at 6 hours, the height of the candle was 0. That means that your candle has now run out in the context of the problem. So the candle runs out at 6 hours. And in the last example, you actually have a height of -4, which doesn't make sense in the context of the problem. So you would have to understand that you cannot burn a candle to -4 height. So this doesn't make sense in the context of the problem. You could say that there is no more candle after 8 hours. Candle after 8 hours. Or you could say that it doesn't make sense in the context of the problem because you can't have a negative candle. So the next question says, how long will it take for the candle to burn down to a height of 7 centimeters? Now, ordinarily, if I gave you a really good graph, you would be able to look this up on a graph. Like you would be able to find 7 somewhere over here, and you would be able to read off the graph what height or how long had passed before that happened. Unfortunately, we don't have a very good graph because we just have a sketch. So what you're expected to understand is that you can take this and plug it into the formula as 7 is equal to negative 2t plus 12. So if you actually solve this, you're going to end up with negative 5 is equal to negative 2t. I'll divide both sides by negative 2. So this is exactly 2.5. So you can say that it was 2.5 hours. The last question asks us to suggest an appropriate domain and range for the function. So we're looking in the context of the problem as to the numbers that actually make sense. So in the time limit, you could say that the domain really only goes from 0 to 6, because after that, the candle is run out, and you can't have negative time, and you can't have a candle past 6 hours. So we're just going to set it here. And because t is continuous, we can put that it's an element of the reals. And the range, if you look at the graph, only really goes from 0 to 12. So we can't have a negative piece of candle. So we're going to say that the range goes from 0 to 12. And what are we looking at the range for? H of t. And that's just another way of writing the y coordinate. So this is the domain, and this is the range. So as I said before, we are not actually expecting you to use a graphing calculator, but we are expecting you to do the rest of the questions. So what I'm going to do for this assignment is I'm going to give you the sketches of the graphs that you would have seen in your graphing calculator so that you can do the rest of the examples. So you can just copy them off of me. This would be the sketch of this graph, which would have the 2 here as the intercept. Here's t, and here's h of t. Question 2, your graph is going to look like this, and it's going to have a very large scale. So if this is the cost in terms of n, and this is n over here, then your y-intercept is very, very large. It's actually that. Question 3 is really interesting because the graph actually makes sense in the negative realm. So we're going to extend this graph this way. And the reason it makes sense in the negative realm is because in the t-axis, t does not stand for time. In this case, t stands for temperature. And you can actually have negative temperatures, which is why it goes into the negative realm. So this is the number of sold as a function of temperature. And we are getting an intercept here at 150. Question 4 is nonlinear. If this is the height, then this is the time, then we're actually going to get one that looks like this. I'll try and do a better job of drawing that. So it looks like this, a parabola. It starts at 0 and goes to 100 over here. And it has a maximum value of 50, comma, 22,500. So a very, very large h-axis. The last question on page 480 is a piece of a parabola. So it starts here and goes down like this. And it hits the ground at 22.924 seconds. And here's the height. And the starting height was 2575. So now that I have given you all the sketches in this assignment, you are able to complete the rest of the questions on your own without needing the use of a graphing calculator.